one of the concepts that people talk about a lot in permaculture, and it seems to be very mysterious, is the idea of guilds. And a guild is simply a group of organisms, usually plants in this case, that come together for a common purpose, come together to support one another, just like the Cooper's Guild and the Goldsmiths Guild and all of that came together for their own common purposes. So this is a presentation software called Prezi. It's different from PowerPoint. It was created by people who hate PowerPoint. And you'll see how it works. Prezi, Prezi.com. You can get it for free as long as you're willing to upload your presentations to their site. So this is up on the Prezi.com site. If you do their search engine, Hemingway and Guild, and spell my name right, you will get this presentation if you want a copy of it. But we're just going to look at guilds. Here's the entire talk. I won't have time today to look at guilds by evolution, and that's good, because it's a little bit of a guilds for botany nerds as opposed to useful guilds. But this is what we're going to do. We're going to cover guild basics, and then we're going to look at 3 different methods of designing guilds. Guilds are a very mysterious topic, but they're actually really easy to do. It's not rocket science at all. So looking at guild basics, just what are guilds and how they work. The gold standard guild that we wish that we could design more of is the Native American triad of 3 sisters, the corn, beans, and squash, where the corn is the trellis and also gives you food, the beans are the nitrogen fixer and also give you food, and the squash is the mulch, ground cover, and also gives you food. So they nest and stack into each other so well that they become an over-yielding polyculture. More food comes off of that guild than any one of those plants, corn or beans or squash, planted into the same area. That's kind of the gold standard. Hardly anyone, no one has been able to invent a guild that works as well as that in temperate climates. I wish we could, and maybe someday we'll know enough to do that. But it gives you an idea of how guilds work. They all are supporting one another with the different functions that they need. So guilds can be really simple. This is just an apple tree with comfrey underneath it. And I'm not sure that the comfrey benefits from the apple tree other than maybe some shade, but the comfrey provides mulch. You can cut it down, just mulch it right in place. It's what's called a dynamic nutrient accumulator, which means that it has a deep root system that pulls minerals from deep in the soil and then concentrates them in the leaves, and then when the leaves fall onto the soil, those minerals then are released into the topsoil, which is where most of the apple tree's feeder roots are. So it pulls stuff from deep in the soil and brings it up to the surface, essentially. It also attracts beneficial insects. It also is medicinal. The one caveat with comfrey is that it spreads by root division, so that if you rototill around it or run a cultivator through it, you will spread it everywhere. So don't till around it. And I've seen comfrey stay in the same place for 10 years simply because we give it about a 3-foot radius of not tilling right around it. It can also be spread by gophers. That's the other way it's spread. They dig up the roots and carry them over to their burrow. But that's usually not as bad as running a cultivator through it. But that's a simple 2-part guild, really easy, and the comfrey is really helping that apple tree. Then getting a little more complex, what we've got is an old apple tree, an established orchard that was then underplanted with currants, which can tolerate a fair amount of shade, though they won't produce quite as much in shade as they will in sun, but they'll still produce. So now I've got another food plant in there. Then we have various sorts of mint, which I would only recommend if you are living somewhere dry where it's not going to spread that much. Fennel, salvia, some various sorts of sage under there, and then comfrey again. So the fennel, the mint, the salvia, and the comfrey are all beneficial insect attracting plants. So they'll help attract pollinators and also pest predators. People come up to me and say, so what's the perfect guild for an Alberta peach? And you don't need to be that specific. You just really think about, what does a peach tree need? Nitrogen, other minerals, pollinators, and whatever will do that likes your area, you could try it. Because if you think about how conventional landscape design is done, they put plants together because they look pretty together, or because they have complementary foliage types, or because they all get the same height or the same color or something like that, and they do just fine. So generally almost any assemblage of plants is going to do just fine. Here we're kind of choosing them because of the roles they play, and they usually will work just fine. This guild is too dense. That's one of the beginning guild makers' mistakes. I have made the mistake, many people make that mistake, is they don't all need to be packed underneath the fruit tree. They will a bee will know how to move from a fennel to the fruit tree even if it's 20 feet away from the fruit tree. So they don't all have to be packed right under it. Nitrogen fixers, yeah, we want to put them near the fruit tree. And I'll talk about that in a minute when we get to nitrogen fixers. Okay, so I'm going to go through 3 methods of designing guilds: structure, function, and analogy, because like I said, the last one by evolution isn't really a useful method. It's just kind of interesting, and so in the interest of time, we're not going to go into it. But designing guilds by structure, all that means is plants that physically fit together well. You can mimic a forest edge. There are various things like that. Just plants that physically lock into one another's shapes well and don't compete with one another in terms of shape. So there are 3 kind of major ways of doing that. One is guilds involving annuals, where we interplant, which just means it's a polyculture, put different shapes of annuals together that kind of fit into each other's empty spaces. Mimicking the forest edge, which is the illustration you saw before, and then stacking in space vertically. If you have enough sunlight, you can stack plants vertically in space as well. So mimicking the forest edge we went through already. It's the same thing. It's just getting that concave shape in the forest edge where gradually shortening trees move out of whatever your large tree layer is. Or we're just physically fitting it into the space. Then stacking in space. This is an illustration out of Bill Mollison's designer's manual, and you can tell by coffee, pineapple, ginger, and cassava that those are local native plants here. This is obviously out of the tropics, but as long as there's enough sunlight, you can do stacking like this. You can see that these big emergent palm trees are not going to be shading these albizias or whatever they are underneath it, and you're still getting shade to this layer. In areas with not as much sun, we just have to spread things out more. But we're doing, here's a productive layer, here's a productive layer, here's a productive layer, here's a productive layer. So we can layer things in. You just have to spread them out in this climate more. And then interplants are ways of putting annuals together so that they don't compete for light or nutrients. And some examples of these are, here we've got an interplanted parsley, spinach, celery, and Brussels sprouts. Brussels sprouts you could think of as kind of the dominant species here, the big thing that's going to take a long time to grow. Celery grows up mostly vertically, not completely, but mostly, so it's not going to shade other things. Spinach grows in a fairly short period, so you'll pull it out and other things will spread into its space. And parsley has light feathery leaves that aren't going to cast shade on other things. So these 4 plants just lock into one another pretty well physically. Same with pepper, tomato, and basil, which that's a spaghetti sauce guild also. But they like each other. These are plants that have been traditionally been planted together for a long time that just fit into each other's spaces fairly well. And then another set, we've got radishes are going to come out really quickly so that their space can be occupied by the slower growing stuff. Pepper is sort of the dominant plant here. It takes a longer time to grow and likes full sun. And then lettuce doesn't mind being in some of the shade of the pepper as the pepper plant grows, because it'll get hot and bolt if it's out in the full sun during the summertime. So they fit together well. And then lettuce, cabbage, and peas. Peas are the nitrogen fixer. Cabbage is kind of the dominant plant. And lettuce will benefit from some of the shade cast by the cabbage as it grows. So we're just sticking things together that physically work well together. All right. So here we're getting to kind of the heart of guild design, because in permaculture we're really trying to design things by function. What things work together and perform roles that the other plants need. So I'm just going to move through that one because we're trying to move through quickly. But the pieces of a guild, if we're designing by function, essentially what you would do is think, okay, what are the functions needed for plants to grow? We need water, we need good soil, fertile soil, organic matter made up by mulch, We need pollinators and insect pest predators. We might need barriers to keep things away. So those are the functions that, say, a fruit tree might want. So what we have in here, and I'm going to go through all 6 of these categories, is we start with a central element, which is going to be some kind of fruit tree or a nut tree or a tall grass, corn, sorghum, even Jerusalem artichoke or a sunflower, if you just have a small space. But what we're doing is a central element that's kind of being served by the rest of the members of the guild. Usually it's a fruit tree, sometimes it's a nut tree, and then we plant in accordance with that. But that's our central member of the guild. And then one of the functions that that central member needs is it needs pollinators. It would benefit from pest predators, things to say kill that like to munch on codling moths or borers or whatever might be your pest problem. And all that really means is plant flowers. Flowers attract beneficial insects. These are 3 that do a really good job, but there are dozens, if not hundreds, of what we call them insectary plants. If you Google the term insectary or insect-attracting plant, you will get lists. Gaia's Garden has a good long list of insect-attracting plants. And these 3 plants with small flowers like lavender and some of the composites, the daisies and things like that. Another family that is really good for attracting beneficial insects is the carrot family, the Apiaceae. Seems to attract fennel and coriander and things like that, attract beneficial insects. Little parasitic wasps that like to eat or lay their eggs on munching caterpillars and things like that that help keep it under control. And these also attract pollinators, which your fruit trees need. But really it's just plant a bunch of flowers, make it look pretty. Then plants to produce organic matter. Plants with big fleshy leaves put out a lot of biomass. You can just cut them down in place and do a chop and drop thing, or you could cut them down and take them over and make compost out of them, but that's more work. So 3 good examples. Comfrey we've mentioned, big fleshy leaves. You can cut comfrey down 2-3 times during the summer, and as long as you give it some water, it'll sprout right back up again. Cardoon is an artichoke relative that's more of an annual. It's in the thistle family, but it's not an invasive thistle. It reseeds pretty freely and puts out great big leaves like an artichoke leaf, but it will live in a cold climate because it's setting seed every year. And it also has edible stems, although I'm not really fond of them, but some people like to eat them. Squashes put out a lot of biomass. Anything that has big, fleshy leaves that rot easily, nasturtium. Nettle, yep, there's one, exactly.
What about rhubarb?
Rhubarb would be another one. Nutrient gatherers. So there are 2 main categories. There's nitrogen fixers, plants that have a symbiotic relationship with a bacteria that fixes nitrogen from the air. In other words, turns N2 from the atmosphere into nitrate, which plants like to eat or need to eat. And then dynamic accumulators, which I'm going to go into in a minute.